Okay, my goal here is to find x, which is this bottom length of this isosceles triangle. I know it's isosceles because the two sides here and here are labeled as 15. I also notice that these angles are congruent down here. This altitude of 12, which is the height of the triangle, essentially splits this into two equivalent right triangles. That's how I know this is a right angle. So in order to find x, what I'm going to do is I'm just going to find a for this right triangle, and then I can double it because x is the full length of this side. So let's focus on this triangle here. According to Pythagorean's theorem, a squared, which is one of the legs, plus 12 squared, which is the other leg, has to equal the hypotenuse squared, which in this case is 15. This is our equation using Pythagorean's theorem. If I square 12, I get 144, and if I square 15, I get 225. Now my goal is just to solve for a to find this missing length here. If I subtract 144 from both sides, a squared would be left, and 225, removing the 144, would be 81. So what I'm doing is I'm removing 144 from both sides to keep the equation balanced. Now, a squared is 81, but this side is clearly not 81. That would be much too long for this triangle. So remember, in order to undo a square, we can take the square root. If we do that to both sides, we get a equals 9. Therefore, this is 9, but remember our ultimate goal is to find x, which would be 2 of these segments. So if this half is 9 and this half is 9, then ultimately x would equal 18. That would be our final answer to find x.